we're going to consider here these three problems very briefly. We've already looked at two of these before, only I actually previously would give you the phase. This time I'm giving you the substance and two independent intensive thermodynamic properties, and then I'm asking you to determine the phase. So let's go ahead and look at each one of these problems pretty quickly. For part A here, you could draw out the problem, and just so that we can see kind of what we're really looking at for each one of the problems in this table. We have a pressure and temperature given. We would obviously like to find eventually the other thermodynamic property, which would require us having an equation of state, which is determined by the substance and an unknown phase. So our first step here is finding the phase. Let's go ahead and do that. Since we're given the pressure and the temperature, we're going to draw the vapor pressure curve, which looks an awful lot like this. And we know that the data that is determining this line is given to us in table A4 or 5, as we saw in class. And we know that this line is special because it basically is the breakover point between phases. On this side of the line we have gases, and on this side of the line we have a curve, we have the liquid phase. So what we want to do is compare. What have we got here? So let's go ahead and we'll look at our temperature here of 160 degrees centigrade. So for water at 160 degrees centigrade, we look at our table A4, A5. Let's go take a look at that. So at 160 degrees centigrade, we can see that the pressure at which we would fall on this line would be 618. And our pressure is going to be much higher than this. What that means is that we are ultimately in the liquid phase here. So that once we've determined our liquid phase, we're going to go for H2O that's liquid. We're going to go use table A7. Let's go ahead and look at this guy here, B, R134A. So R134A, I still don't know the phase, but I know that the pressure is 0.55 megapascals and that the temperature is given to me as 120 degrees centigrade. We want to find the volume. We need a governing equation. Everything is exactly the same, except now the substance is different. R134A, we don't know the phase, so we draw a very similar picture. The vapor pressure curve, but now it's going to be the vapor pressure curve for R134A. So if we jump to table A11, we have the saturation curve data for R134A, and we can go ahead and look at our given values. We have a temperature value of 120 degrees, and if we look in the R134A table, we see that 120 degrees doesn't appear. We're probably above the critical point temperature, and so we're probably gas. Let's take a look though. What we can find is 0.55 megapascals. That's the same as 550 kilopascals. So if we go ahead and look in this table, we got 570, 530. So between 537 and 572 kilopascals, the temperature on this curve would be between 20 and 18. So we know probably close to about 19 degrees centigrade would define this point on the curve. Our temperature is way above that, and so we can see that our phase here would be gas. And let's do one more problem here. We'll do the last one here, which is H2O. So we have H2O. Once again, we have a pressure of 0.265 megapascals, which is just 265 kilopascals, and a temperature of 110 degrees centigrade. we would circle these like we should have on all the others. And to find the phase here, we're going to go ahead and draw the vapor pressure curve. Liquid and gas. And let's go look at the table for what determines this is table A4A5. A4A5 gives me this data. So if I go to table A4A5 and I look at my given temperatures, so at 110 degrees, my pressure that I can pick off is going to be 143.8. My pressure is 200, this is in kilopascals, my pressure is 265 kilopascals. So I'm up here and I'm a liquid again. So we found liquid, gas, liquid to be the phases. And once I found all of those guys, of course, writing this out one more time, we didn't know what it was, but now we've figured out that of course it is liquid. So what's our table going to be for our EOS? Table A7. And that's how we do these problems. Once we've figured out our table, we interpolate as we normally do.